What's up, y'all? This is Hussein Nasser from IGeometry, and today we'll continue with our second episode of add-in programming. I didn't give it a name to this series yet, but it's called ArcGIS add-ins for now. But maybe I might change the name, but still we will reflect the actual concept of this series, but gonna just tweak it a bit. So I spent the last week thinking about the context of this series, and I came up with something that I think it's a good idea. So we're gonna do we'll take a fake company that I created. So I spent some time creating a user story of a company which is failing. It's a telecom company which is failing to serve their customers, and customers are leaving their this provider to another providers because of basically poor signal reception and other things. So they did not keep up with the technology, so people are leaving them. So those guys came to us asking for help. So they never heard of GIS. They don't have any sort of database that store this information. All this information is stored somewhere in Excel sheets, and or their customer information is, let's assume they are on sheets lying around, paper, this, this, and you know, it's unorganized. What's the word I'm looking for? Dismantled information. Yeah, I think so. Yeah, it's not focused. It's not centered into some centralized location. So they have a bunch of uh, scattered. That's the word I'm looking for. So scattered kind of data and information all over their organization. So they are not organized enough to have a centralized database, not geodatabase. So they don't have a centralized database of this information system. So they have written something, some user story, and we're gonna go ahead and open that up. It's a text file that I wrote, and I'm gonna read that. So the steps to that is that I'm gonna go ahead and read that text file. And this text file is contains the actual, think of it as a requirement. So you guys and me basically will be the software company that solves their problem. So they ask us to use to help them, and we're gonna use, of course, since we are geo geeks, we're gonna help them solve this problem using geographic information system, and in this particular instance, Esri technology using ArcGIS. So we will start with building from scratch, right? They don't have a database, so we have to build one. So we have to provide some sort of information model for these guys. They don't have anything. So we need to listen to their requirements, the requirements that we made for them. So this the CEO of the company met us, and he gave us his like dream thing that he wanted to accomplish. So first step is we want to develop some sort of an information model to fix their problem, the geodatabase, and then with that information model again, we will write the geodatabase, construct the geodatabase, whether it is enterprise or file geodatabase, doesn't matter. It's just a file geodatabase to start with, and then we're gonna connect ArcGIS to this geodatabase, and then we're gonna build cool tools on top of this data model. Right? Sounds good? Let's go ahead and read this. So I asked you guys, apparently nobody answered, so to come up with a name for this company. So I don't have any name. So I asked my wife, and she came up with this name. Right? Sounds cool. I don't know. We search online. There's no company by this name, and if there is, forgive me, we don't know you. You didn't come up. You didn't come up in this Google search. So it's called Phonatech, right? So Phonatech, whatever. All right. So phone, from a phone, and tech. That's a cheesy name. I'm sorry, but whatever. Right. So Phonatech is a telecommunication company that provides cell and internet services. Okay, this is their core business, right? So what's wrong with this company? Phonatech has been suffering from bad customer reviews regarding poor services, despite constantly adding new towers. By towers, we mean here cell phone towers, right? So these are where basically your phone connects to get reception and signal and internet and everything else, right? Uh, so those guys are keep adding new towers and spend money on these towers, but apparently cell reception is not getting any better, right? So they're doing it wrong apparently. So they are adding random towers in random locations without measuring. We don't doing any geospatial analysis to find the optimal location, right? Things that we will be doing as geo geeks, right? So Phonatech does not keep track of customer locations. So that's another problem they have. So if the government contacted Phonatech, says, hey, we're looking for one of your customers. His name is whatever, Fu. So we're looking for Fu, and we know you guys are provider for him, and we're looking for him. He's lost. So can you provide me his last known location? When was he connected, and to which tower was he connected? So these guys say, we don't store this information. Sorry, Your Honor. So we cannot help you. So that's bad, right? So our information model for those guys should support storing customer location, and not only customer location but constant customer location. So this is a huge data, all right? So think of that. So when the moment you connect, so the moment you move, you connect to a tower, you get registered to this tower, and the moment you move from that tower, you connect to another tower, you get registered too. And the registration is done via, of course, your phone, what they call it, IMEE, International Mobile Equipment Identity, I think. So this is what they will be. So we're going to talk more about that. We're going to dive deep into the technicality of this. So they want to solve this problem. So we always look through things from a high bird eye view to solve a problem. So this is the problem they're facing, right? So they're facing a problem that they have bad reception. So their towers are misplaced properly. And the second problem is they don't store this customer information. So even if they do have towers and they have good reception, they don't know where are their customers at. Of course, this is a security issue, but whatever. We're gonna help them. This is a privacy issue, not security. So the privacy issue, but we're gonna help them invade our privacy, like every single cell company in the world, basically. Yeah. All right. Hey, by the way, I forgot the magic mouse, the shitty magic mouse. Now I know how it works. It turns out I have to update my MacBook Pro from Yosemite. What was that operating system? From Yosemite to El Capitan. When I did that, Magic Mouse worked like magic. Haha. Get that pun intended. Right. You were asked, the second thing. You were asked, so here's the part where we get involved. Still, it's messed up. I still don't know how to use this scroll. All right, so where are we? All right, there we go. You were asked by Phonatech to implement a solution using GIS for them to enhance their cell reception, manage their new implementation of 3G and 4G networks. So, they are planning to implement 4G too, so they don't have that. And they want apparently to search and not search. They want to establish coverage for 4G and show, for example, which areas have 4G. So if you're a new customer, you want to apply for an internet, and you want to check if your area, if you want to apply for Phonatech, of course, right? And you want to check if your area has 4G or not. Are we recording? I was a freak out. Yeah, good. We're recording. Okay, good. Okay, guys. All right, so this is one of the basically examples to do that. So Phonatech have three types of towers. This is a very important piece of information. Okay, so towers have type, right? So now we're gonna do some costing. So we are seeing some numbers here: 5,000, 2,000 types. Now we're diving deep into details, and each single line here gonna be converted either to a table or an attribute or a domain. So this is that's what I wanted to do, guys, really. To go through a real life scenario and convert it into an information model and then geodatabase. And then from a geodatabase, we build up, right? So this is how the word works. So I really hate it when there is a book that want to teach you on technology and they just dive deep into APIs and talk to you about functions and features that are random features, and you don't know what. Okay, when I'm supposed to use this, you have no idea. So I have no idea even what I'm gonna use in this example. So I made this up, and I'm gonna go with the flow. Whatever we need, we're gonna add. So this is how the real world, real projects work, basically. So I don't know if this is gonna be difficult or hard or simple, or I don't know really. But I assume this is not a very difficult implementation, but it's gonna take us a few episodes, hopefully a dozen episodes to go through this implementation. All right, so Phonatech have three types of towers. Type A, which costs $5,000 to build and install, right? And it has a coverage of 700-meter radius. So we're going meters here. So let me explain this real quick using our magic paint, right? So here, this type A, this is one of their towers. So apparently this tower has the largest radius. So if this is a tower, where is it? This is our tower, this location, and it will have. God damn it! Delete. Okay, I can't delete. Wow. Okay, whatever. So it will have a 700 radius. So this is the tower. So this will be 700. Right? Got it? So if you're here, if you're really next to the tower, you're gonna get 100% reception. So 4 bars or whatever, maximum bars. If you're here, you're gonna get 0 bars. If you're here, you don't get any signals. Got it? So that's a very simple representation of that. Guys, whoever are in the telecom business, this might not be the correct way, but this is just for clarification. So this is disclaimer. This is not the actual correct way of calculating it. But I'm doing this just as an example. And if there are any telecom guys out there, please chip in and do share the actual correct algorithm or equation to do that. I'll be very, very, very interested to know how this really works. But this is just from very basic understanding of telecommunication, basically. All right. So this tower has a 700 Apparently, this is a very high-tech tower or whatever. So it's the largest one. Okay, and it costs 5,000. So it's a pretty much expensive tower, right? They didn't tell us the height of that tower though. The height is very important. But anyway, the second type of towers are type B. They cost $2,000 to build. Probably this is an undervalue that I put. I think they cost much more, but anyway, guys, you get the idea. This is a 300-meter radius, and type C costs 1,000. So not much difference between type B and type C, but not even much of a difference of the meters, right? So the radius is only coverage of 100 meters. So now our cool solution have to combine these three towers somehow and suggest a plan, for example, to use these three towers to give maximum coverage plus minimum cost. Does that make sense, guys? So this is what the word cares about, right? You want to spend less money as much as possible. You don't want to spend a lot of money, unless a lot of money gives you a lot of value, right? So each tower type has a different base area. Oh, this is very important, guys. Just added that literally yesterday. So each tower type has a different base area, which is important as towers take a place of land, and land are rented out per square meter. So not only there is a one-time cost of 5,000 to build the damn thing, but there is another cost, which is the area. So there's an area, right? And the area, the tower is built on a land, and the land gotta be rented or bought. So if you're gonna rent, so for example in Bahrain, back in Bahrain, they give out people who rent part of their property to put towers in them. So telecom company actually pay residents and individuals like $1,000 a month to rent their property just to put the tower there. This is good. This is good income apparently there. So yeah. So this gonna be added to the cost, right, of implementing this. So we have what? Which add additional cost to the installation of the tower. Type A has MN. Wow. English, saying English. Type A has a base area of 60 meters square and a height of 60 meters. The height is very important, by the way, guys. I don't know why, but I just feel it. I have a very big feeling that height is gonna bite us in the bottom later. Type B has a base area of 40 meters and a height of 40 meters. So 40, 40. Type C is a base area of 40 meters and the height of 30 meters. So it's not very long, right? But this is a very long one. 60 meters long. It's a very high tower. All right, another piece of information here. Each tower can be configured to support only one network band by default, which are the following. You can either support one of the following only, right? Again, guys, if you have any telecom guys out there listening to this now, I'd be glad. Chip in, please. But this is just an example. This is not how the actual work, but I give this as an example. It's a very simplified example, just to illustrate a concept here, right? So this is the concept of domains, basically, that as we will see. So 2G, 2.5G, that's called edge 2. 3G, 3.5G, that's HSPA, or if you have Samsung, or this is usually called H plus. There's another called H plus. There's H and H plus, right? And LTE, right? LTE is a long-term evolution. Very bad name for a network. Long-term evolution. What the fuck with this name? And 4G, the fourth generation. All bad names, by the way. Your solution, your solution, your solution. Your solution should be able to provide the following. Oh, come on, finally. Hussein, I know, guys, I hope you're not bored. I have to go through this. This is real world stuff, right? I don't want to jump to coding and add-ins and ArcObjects and layers and maps. So we have to know what the hell are we building, right? This is very important. Bear with me, please. Don't close the video yet. All right. Calculate the signal. So one of the solution we're building have to calculate signal strength for a given point in the map. And a point is basically a customer location, right? So if we are here, this is we talked about this. If we're here, we want to calculate the percentage of the signal, right? And I have just a formula to do that. It's very easy. We're gonna talk about that when the time comes. All right. Find dead areas. What are the dead areas? They are areas with no signal. So if you have, where's that? Where's the point? Okay, so if we have like a tower here, wow, that's a very nice tower. Can you top that, guys? Like type A tower here, okay? Another type A tower, and another type A tower, and whatever type B. So they can overlap, it's fine. The range can overlap, right? So this is another type A. So what are the dead areas here, right? So this is a dead area, right? This is a dead area, this is a dead area, this is a dead area. So these are dead areas. So dead areas where you cannot, where your signal is 0, or your closest tower, okay? And this is a very important thing, by the way, that we do geospatial analysis on that. So if I hit here, which tower is closest to me is the one I'm calculating the signal to, right? So this is how the real work, or the real world works anyway, right? So we calculate the signal. So what is this exactly? Yay. So this is the, we don't have any signals here. Nice. So dead areas. How about that? You think this is exciting? I think it's exciting. Please leave a comment if you think it's exciting. What to do, right? We're gonna jump into the geodatabase very soon, guys. Propose cell tower location to maximize reception and minimize the cost. What does that mean? All right, nice. So we will build tools and tools on top of ArcGIS that actually help us determine the best location we can put a cell tower in, so we have the maximum coverage. Does that make sense? We're gonna build that, but that's actually, it's more difficult, so I'm gonna move it to a next difficulty, perhaps, because this will require analysis and trial and error, you know. So we will write a code that, and we'll run it on a particular area, and the computer or our tool will suggest locations, and not only locations, suggest also towers, right? So that would be very cool, man. I can see this application gonna be cool, guys. It's better than that restaurant application that we wrote, guys. Yes. So if you, for those who are new, I've written a series of, I think, 23 episodes on extending ArcObject, and I use an example for a restaurant management application. So you are a customer who want to search for a restaurant, and we're building a tool for you to help you search restaurants, add restaurants, rate restaurants, something like that. You know, review, all these things. So we built a geodatabase. But the thing with that example is that I built that geodatabase behind the scenes, and I just gave you the geodatabase, and I didn't like that. But I just thought that I want to do that just to simplify, you know, to simplify the process. But apparently, it's really good to show the process of developing, and not developing, just creating the geodatabase and adding these feature classes, and why do you choose a point as opposed to line or polygon, or subtypes and relations and all these things, you know. So in this series, we're gonna do just that, right? Might be boring for some of you guys, but I have to do it. I just let me know, right? But it's gonna take more than one episode to do that. We're gonna finish it hopefully in this episode. All right, so capture and store connected customers, phone, international. Oh, we talked about this, right? So international mobile equipment items. So phones who are connected to a particular tower will be registered for that tower. So there will be, each tower has a list of connected customers. So whenever, not connected customer as live customer, but customers who connected to this tower. So users who connected to this tower, basically. So that's what it's gonna be. All right, so we're gonna save the IMEI number of the phone, because each smartphone or phone has this number and it's unique internationally. So we're gonna use that as so if I know your IMEI, I can know where have you been, basically, in my life. That's not that. Forget about that. I was quoting Rihanna song. Location lat long for each tower. Ability to locate the last location for a cell. We just talked about that. Provide heat map. That's intense, guys. Heat map. Yeah. So what is a heat map? Heat maps will give you like the. Let's Google that. I'll show you. It's better than. So heat map. Hopefully no porn will show up. So this is a heat map. Something like that, right? All right. So it will show some sort of a heat map for 4G network. You know, it will highlight the areas that has 4G coverage, and so we're not talking about signals anymore. We're talking about actual 4G coverage. So each tower will either be a 4G, 3G, 2G edge, right? We said that, and each tower can only have one band per se, place, right? So we're gonna use that to draw that, right? And we can do that. Nice. Cost management module, calculate the cost of the rent. We know that about that. So first thing, finally, build the information model. Booyah. And then second thing, we're gonna do the create geodatabase and feature class and tables. That's what we're gonna do. Let's do that. All right, guys. So save that. And we're gonna build the information model. I usually, to build an information model or ER diagram or whatnot, you need basically a tool that draws that, and I like to use Glyphy. I never used it for a long time, so let's just start drawing. Hopefully he will let us in. I don't need to save anyway, it's just start drawing, yeah. Alright, can UML class, UML will do actually. Yeah, we can use the UML. Oh no, yeah, entity relationship, that's what we want. Alright. So, what do we have here? Let's go back. So we have this cell phone company, right? So it's called Phonatech. Phonatech has towers. That's the first thing, right? So we will have a table. Is it a table or a feature class? So what's the difference between a table and feature class? For those who are new to GIS, a feature class is a table which has a geometry type. That's the only difference. So it's called tower. All right. All right. So, and it should be a feature class, right? Because towers has locations, and they are do you think it's point, polygon, or line? That's by the way, these the three things that a feature class can be, and obviously it's a point. This is the location. This is like this Picasso drawing right there. This is the tower. So tower is a point. Okay. So what does the tower have? What does the tower have? That's correct. Okay. So a tower have, let's call it a tower ID. It has a name ID. So that's a string. Probably that they didn't, if you notice that they didn't say anything about a tower ID, but I'm just assuming that they will be numbering them or giving them some sort of a name, right? Like tower T1, T2, T3, or T whatever. Right, my coffee's done. Tower IDs, what's the next thing that the tower has? We talked about the tower have either, they can either have this, let's go to the, they have a range, they have a coast, right? They have a type. Let's do tower type. Tower type is again string. And this is not actually, not any kind of string that you can type. This is a lookup value, right? So, or we call it a domain, right? All right, so tower ID, tower type. Can I move this to the left? That would be great if I can do that. Where's that? Yay. What? It doesn't like me doing that. I have to sign up. I have an account, by the way, but I don't just... All right. Tower type. A, B, C, right? Now, it's up to us to be really smart about that, you know? Shall I put this information, the coast, the radius of the, that's the coverage. The coverage have to be where exactly? I can do it like this. So we do it the denormalized way. So coast of the tower. We can put the coast as double. That's the tower coast to install. And we can put the coverage, tower coverage. That's again double. We can do that. We can, what else? We have the height, tower height. That's perfectly fine. Tower base area. That's again double. What else? We have the height, we have this information. Each tower, okay, I think that's it. And we have, each tower can be configured to support only one network band by default, which are following. So we're gonna call it network band. And that's again string, that's the domain value. I'm gonna select from this. So, and of course the final thing, and we're gonna, of course this is not the final, this is not the final design that we're gonna be making, right? This is just part of it, really. And we can easily add as we need in the future. So that's the process of basically the agile process. So what you want, you read the documentation, you read the requirements, you implement, and you go back and you implement in bursts, right? So you get another chunk of implementations or requirements, and you implement them, and you go on, right? So that's the loop. So network band, yeah, we say the network band, and what else? I think that's it. So there is something really bad about this design, you know. Some of you have already guessed that, I guess. Okay. Again, if not, think about it for 10 seconds until I finish this up. So there's something really bad about that. Why? So this is why what someone will basically develop that as tower ID, tower type, and cram everything into one table as a denormalized version. So normalization versus denormalization, right? Normalization is to have as much as possible granularity, right? To granulate things, you want to separate things into table and do joins. So normal people like to do joins apparently. Denormalize is bringing everything. This is the big data approach where everything is bringing back into one single table or feature class. Either way are good. It depends really on your solution. So in our case, which is what's bad about this is we're cramming values that are almost constant into one table, and that's wrong because I'm gonna give you an example. Why I cannot right click this thing? Thought I can right click. Stupid magic mouse. I'm gonna use my. This is $70 for this. Can't believe it. Paid for $70 for that thing. All right, so let's add one record, for example. So we have tower ID, tower type, cost, height, coverage. All right. So tower ID T1. The type is A. Cost is what? Type A is very expensive, 5,000. Then height is whatever, 60. And then 700 meters. Remember, what if we want to add another tower, T2, which is again type A? So you're gonna repeat all these informations again. So that is, I don't like to say it bad, but it's repetitive, right? You're repeating this information, and in case of any change, you have to go and update all this information. Like, but I don't like to agree with that either because you cannot update obviously sometimes some characteristic of a tower can get updated, but like a range can get you can go and tune the tower type A to be like 800 cover. It covers 800 meters instead of 700. So in this case you have to go and update this table, and that's bad. But another approach, if you guys already figured out, is to pull this information into another table. That's what we actually going to do. I'm not saying one method is wrong and one method is right. Okay, there is always a silver lining for each method, and you have to find out what is that silver lining. Because it depends on your solution. Sometimes you said, hey, my towers will never get updated. Okay, so I don't have to put in another table. I like it. I like things to be in one table, and that's easier for me to search instead of doing joins. So and that's fine too, right? So get over it, really, guys. It's just very very simple. So some people are really, you know, they always like to do things normalized. I don't want to be. I don't want to give you the impression that normalization is the correct way or denormalization is the correct way. There's always, it always depends on your solution. I've done a lot of projects, and sometimes I use normalization, sometimes I use denormalization. I like to put things, especially if this is a huge project and I'm gonna do a lot of queries and the data is massive. Probably you want to, as much as possible, minimize your joins, right? Again, so the classic tower details. So we have tower type, and we have so we can use tower type here as the string domain. Now we can use this information now. Tower cost, double out. How about that? We just copy it. And the network band. Now this is really interesting. Network band does not go on the tower details because network band can change for a given tower, even if they are the same type. Correct? All right. So that once we finish that, we're gonna go to the fun part. ArcGIS. We still didn't write a single line of code, guys, but it's fine. I'm gonna get bored of coding, believe me. I love coding more than anything else, but we have to do this. We have to do the correct way. All right, so we have shape, tower type, network band. Yeah, so tower type, if it's A, we go search here. Yeah, we have to put tower type here, so yeah. Tower type, and that's a string. That's the domain. Okay. I don't know if we can join on this, but we'll think about it later. Okay, what do we have here? That's it. We have a feature class tower, and we have tower details. And remember these guys mentioning something about recording their customer information, right? So capture and store connected customer phone international. So how do we do that? For each tower, so tower ID is the unique number apparently, right? So this is our unique. No two towers can have the same ID. So what we do is basically we can create another table here. Wait, we didn't. That's 1-to-1, right? Yeah, that's 1-to-1. One tower can have one piece of information and details, right? So all these details are set here. Okay, so in case of any change of these details, you only change this table, and all these will basically reference the latest updated values. All right. So here we can call it tower log. So this is the log of that tower. So what are the customers who connected to this? IMEI. I always forget that. So this is a string, and let's call it. That's just for fun. Gonna add something log ID. No, I'm not gonna add that because we have object ID by default. By the way, each table and feature class you create in the geodatabase, it has object ID, and the object ID tells just a sequence number that generates, right? Very bad. Don't depend on the object ID ever in your life to I don't just don't use the object ID in any referencing or joining and anything. So I don't like to use it because it changes when you copy it and paste it. When you export it, this get messed up. So there's the concept of GUIDs and global IDs. We might go over it. I don't know. We'll see. Global IDs are much better. They are preserved, at least in these versions. Hopefully they don't touch it. So IMEI, what else? We have, of course, date. Date is very important. When was this? Look at time. So there's another date. What else? We have IMEI, date, time. What do you want? Which tower did you connect it to? Right? Tower ID. So I was connected to this tower at this time, and this guy has connected to this tower at this time and this date. Okay, and another record, another record, another record, and that's it. Yeah, tower ID. Sweet. And that's a massive table. This is going to be a massive table, right? And not every single tower will have. That's why I love Glyphy. It's very easy. It's better than Visio. See, in just a couple of clicks, I did this ER diagram. but I think I cannot export it. I have to like, they will make me sign. Okay, damn it. Yeah, but I think I can at least screenshot, right? Damn it. I don't know where's the print screen in this Mac. Anyway. Gonna sign up later, no problem. I'm gonna save it after the video. But this is my information model, like basic information model. I hope we covered everything. We might not, but as we progress through the solution, we will learn that we have not or covered it or not. So now, guys, we have done the information model. Yeah, we have done this part, build the information model. We have the database, not the database, actually model. Now we create a geodatabase. That's the actual physical part. I could have opened our catalog and started doing that directly, but this part was, I think, fun, right? Just to, it's better to visualize things. It's always better to visualize, write things up either in a piece of paper or a model, so we can basically it makes things very easier to do. All right, so folder connection. Now this is our catalog, by the way, guys. Okay, our catalog version 10.3 for desktop. I'm advanced license. All right, you can create the geodatabase and locally. So what we're gonna do here is we go to folder connections and we're gonna connect to a folder that basically does not exist yet. So going to this PC, we're going to, you can use the same locations if you want. I created a folder called IGeometry. It's empty. I'll create a new folder which is called Phonatech. That's a funny name. All right, so this is a bug. You have to click and then you do boom. That's it. Right? We have this now. Okay. Now we can go ahead and create a new personal geodatabase. Oh, interesting. By the way, they will remove this personal geodatabase in 10.4. So say goodbye to these guys. This is the Access version. I think they will remove. I'm not sure, but file, it's gonna be there. File personal. Bye-bye. So see all these kind of data that you can create. There are different types. In my book, the second book, I explain most of them. Learning ArcGIS geodatabases, I think, yeah. So I explain all these different things, but I'm gonna explain them again here if you want, but if we have the time. So we're gonna create a file geodatabase. This is an ASRI proprietary geodatabase. So what do we call it? What do we call it? We're gonna call it, guess what? Phonatech, exactly. So we have the geodatabase. Now what? First thing we're going to create is what do we have? We have a feature class of type point. We have two tables connected to that, right? So one feature class, two tables. Let's start with the feature class. Right click on that, you go to new, and then you say feature class. Okay, the feature class, it will prompt you for the name of that feature class. The feature class name is tower. Okay, alias is the names that if you have like a weird table name or feature class name like underscore tower, a Phonatech underscore tower feature class, whatever, you can just name it very nicely here. All right, so tower, or we can Phonatech towers or cell towers, whatever you want to go. So this is the alias. This is what you can put spaces in here, right? So you can put whatever you want to do. Hussein's towers, cell towers, whatever you want to call it. This is actual physical table name. So you cannot put weird stuff here, right? You cannot put a dot, you cannot put a semicolon, you cannot put a space, obviously. Type of feature stored in this feature class. So what is this? Is it a polygon, line, point, and some weird other type of geometries that we don't want to talk about now? Okay, so it's a point. Are we supporting Z's and M's? Are we supporting route data? No, we're not gonna route through the data. We don't have network analyst anyway. Z's are, sometimes it's important, but are important for things that have three-dimensional location. So for example, towers does not, actually they might, we can put Z's. So for example, if you have a tower on top of a mountain, that's a Z value. With respect to the sea level, it has a Z value. Let's put that. I don't know. Let's make things interesting. All right. So what is the? Oh, I always forget this. We're gonna use a projected. I need to take the default name for Google. I forgot. Was that Word? WC. I forget what's that. It's, I think this is the one. Not so sure though. Maybe this one or this one. Always forget. Yeah. So we have to take the WGS, and this is the spatial reference used by basically everyone. But there's, as you can see, there's a lot of spatial references here. So we're gonna pick the generic one. I think this is the one. Let's go with that one. All right. So that's the Z coordinate system. So it's even I don't know what's that really. Let's see, WGC, same thing. Tolerance. So when you create features, when you create features, what are the minimum tolerance after which those two features will be identical? This is hundredths of a meter basically. So just accept defaults and say next. Configuration keywords. This is, so the option uses the default storage parameters. So if you sometimes some tables, there is a concept of table space, right? So some tables, some feature classes can belong to a different data files because they can significantly get very large. Like this is a very perfect example with us. Tower log, for example, I know that tower log will get extremely large, so I probably want to assign it to a configurable user, like 4 GB or 256 terabytes. So I expect it to be large, so I put it aside. But these things you don't really care about it if you are doing a file geodatabase. You want to do it when you have an enterprise, badass enterprise geodatabase, right? So next, this is the fun part, the actual attributes. So, all right, tower ID. Let's do that. I usually like to use things as capital, always caps. So tower ID. That's text. Leave it as tower ID. This is the alias of the field as will appear in the what else we have? We have tower type. That's our domain. I'm gonna add a domain, tower type. That's a text too. It's not 50, but I don't care. Let's just leave it as 50. It will literally be 3 characters, A, B, C, D. So let's make it 5. Right. Network band. Network band is another text character. Network band, and that's let's put 10, like HSPA. That's a maximum character. This will be, these two guys will be domain values, and we're gonna create a domain just in a second. All right, so what do we have here? Shape, and the shape is already there. Thank God. Finish. Feature class created. Hey. Now we have tower log and tower details. Let's create the tower details. Before we do that, let's create the domain values. So you right click on the geodatabase and you go to properties, and then you go domains, and this is where your domains will be, right? So what domains do we have here? We have, by the way, we didn't create domains here, but I'm gonna create them directly here. So we have a tower type domain. The list, this is the description of the domain, the list of tower types, whatever. So what is this field exactly? I know this is a text, and it's gonna be, the domain values are coded values. So coded values are discrete values. So for instance, we have tower type A, right? Type B, and type C, right? Type A. This is the description. This is the actual code that will be stored in the database. This is what we will show basically when we query or we want to display to the user, we display that. But the actual value that will be stored is A, B, C, right? So type B, and so much for the magic mouse. All right, let's use the magic mouse now back. Tower type, network band. A list of available network bands. All right, so this is again text, coded values. So first value is what? 2G. Let's just call it 2G, right? 2.5G. I don't know if we can do that, but this is text, so I don't care. So this is 2.5G. Or look at edge, we can do that. What else? We have, what do we have here? Not here. We have here, we have 3G, 3.5G, and yeah, so 3G, HSPA, which is 3.5G. Just call this edge, how about that? Right, edge 3G and 4G, right? Or let's do it LTE, because whatever they say LTE is actually 4G as LTE. Actually, LTE comes before 4G. 4G, nobody actually scored a 4G as per standard. LTE is the next thing. So it's always marketed as 4G, but they never reach 4G stage yet. All right, we have our network band. Now we go back to our nice little feature class, and I cannot try to click this stupid mouse. There must be some things I have to do, but I'm gonna look it up, guys. If anyone knows how to use this magic mouse, please feel free. Tower type. Now when you go here to fields, and you go to tower type, and if your text and length matches, you should see your domain here. So we're gonna select tower type, and network band. Since is type text and your domain, you will get a list of all text type domain, and voila, we have ourselves a feature class with domains. Nice. Let's go table. What is our table? Tower details table. Yay. Are we still recording? Yeah. Tower details. So we can, for example, put tower space details. All right. We can put this in the default, and again, same thing. Tower type, tower cost, tower coverage. tower type, that's text of 5. Oh, sorry, we said tower type, tower cost, that's double. There's no domain values for this. I mean, some people put domain values for cost, but it's not recommended. I mean, it's just annoying. Tower coverage, that's again double. Also, you have like standard, like coverage can either be 100, 200, or 700. It cannot be anything else in the world. Then probably you want to do it as domain values, but not really. I don't think this applies to us. So tower base area, that's a tower base area. Again, that's a double value. That's fish. I'm not gonna change these. It's just too much. All right, final thing, the tower log. The log of the tower. This is a very big table. It has the IMEI. That's a very large text. I don't know how large, but let's just put 200. Or to be just fun, IMEI length. I think it's 17 or something. What? So, oh, yeah. So it changes. 35, I don't know. If it says anything. I don't know. Whatever. Let's not waste any more time. Let's just put it 200. Bad idea, guys. Don't do that. But if we're doing real project, you probably do more research than me. Okay, so we have date, time, and tower ID again. Tower ID, which tower ID you're connected to, that's a reference. I think we left it as 550, right? Yeah, and we have the date and time. Probably we'll just leave it as just date. And date can start, so log date we can call, because date is a reserved word. All right. Tower ID is not a domain value, so finish. Now we have a table, feature class, and two tables. One feature class and two tables. We create relations. Relations things are optional here, you know, because we can always join using, we can join using the tables and ArcMap. So I'm not gonna create joins for a lot of reasons. Is that joins create a lot of restriction for us, especially in ArcGIS. So I'm gonna avoid them here. Maybe if we needed them, we're gonna use it, but I prefer not to, because sometimes you want to use like SQL joins instead of ArcGIS joins, because it adds a lot of stuff to you that you don't need. But it's not bad per se, but it just added too much restriction that you might sometimes want to avoid. So leave your tables like that, and we know how they are connected. So what we want to do now, but sometimes you want to create this kind of relationship to manage the consistency of your data. All right, now we have a table, two tables and a feature class. Let's test that. How about that? Let's open ArcMap, and this will be our last step. I'm sorry guys if that was a long episode, but we have to do it. We have to do it the hard way. All right, so this is ArcMap. I am going to add the feature class I just created. So this is good practice for people who didn't work with ArcGIS, I guess. So we're gonna add our tower, and it has this nice little, by default, the symbology. And I don't like this symbology, so I'm gonna search for a new symbology. Hopefully there is a nice. It's updating the index for the first time because I didn't use. That's our nice tower. Or this one. Which one you like, guys? The Eiffel Tower. This is the Eiffel Tower. Nice. And now I want to add my base map. So we go File, Add Data, Add Base Map. We're gonna choose. I'm connected to the internet, obviously, so we'll use this. And hopefully this is the same spatial reference. If it's not, I'm gonna copy it and I'm gonna change it for the next time. So it doesn't show. Does it show here? It doesn't show, I guess. Yeah. Yeah, I don't think it shows. So zoom to layer. So this is it. Let's go to, for example, North America. North Dakota. Let's use the magic mouse. So now I can create features now. For example, let's go using the editor. I'm gonna create start editing. Oh God, I've never done this for a long time. This is the feature pane, basically. So we create a single feature. The moment you create it, it's saved. It's not saved, it's just added to the map. Okay. Now I can click here and assign attributes for those features. So like a tower ID, like say T01, and then tower type. Now this is the font type. Hey, I can select. You can't just type anything you want, right? It can be none or null or null. It's null, yeah. So nothing or null. There's a difference between null, null and db null, by the way. And yeah, so null in C# and db null is totally different values, guys. Just for so you know. And yeah, network band, I can select that this guy is basically HSPA, or you know, type A, type C, type B, and then so we're gonna go ahead and save data, and we stop, and we have ourselves a nice little tower right there. So right click. For those who was trying, who saw me like editing this, I was trying to right click with this magic mouse. It's editing. So add data. Let's add the tables now and start to record a start editing tower log. No, I'm not gonna add a tower log. So this tower details is gonna be literally 3 record. if you know what I mean. It's literally 3 records. So why I cannot select anything here? Because we didn't assign the domain value for this. So we can go ahead and close that. I don't want to save my edit. I don't want to save my project. We didn't do that. That's bad, guys. Go to the tower details, fields, tower type, and then we assign a domain value. I cannot do anything. Why? I think once you create it, you cannot edit it? No. Something is wrong. I think it's locked because someone is connected to it. Yeah. It got locked. So when someone using your geodatabase, nobody else can, basically. Apparently, ArcGIS got confused, but it was connecting to itself for some reason. All right, so once we do that, we're done for the day. So let's add tower details. Let's add the 3 records, and then we're done. Yeah, Tower A. The cost of Tower A is $5,000. The coverage is 700. I know because I made them up. The height is 60. And the area is, I have no idea. Was it 60? Yeah, 60 and 60. All right. Yeah. Sweet. Let's add type B. So literally it will have three records only. Okay, type C. This is 1000, I guess. That's 300. That's 100. The coverage. The height of this is what? 40, 40. Yeah. Yes, so 40 and 30. 40 and 40, 40 and 30. So the height is 40. That's 40. 40 and 30. All right. Save. Stop. And that's it. We have our lookup table here. We have our nice feature class. Let's add it again. And see, it added as bad. We should have saved that project, but let's go ahead and save it. Why not? Because why not? Why not? I'm gonna add also the base map. File, add data, base map. Sweet. What happened? Are you crashing? Not crashing, are you? That's because of the bad spatial reference, apparently. I'm gonna fix it. Alright, guys. That will be all, guys. I'm sorry if this was a long episode, but gotta be, because this is like the setup of the whole thing. So it's gotta be a long episode. So let's save our project here. Let's call it Phonatech. That's not Phonatech. And yeah. Hope you enjoyed it. I hope you learned something from this episode. Very long, I know. We took, so it was very summary. So we took a user story and we tried to create a geodatabase, built an information model, and we built a geodatabase on top of it. Next, we're going to build some cool tools, guys, using ArcGIS desktop. So we're going to build add-ins. I'm going to use these, all right, this geodatabase as the base of our work, basically. So stay awesome. I'm going to see you on the next one. Goodbye.